Another measure of spread is called the standard deviation. Occasionally, we'll calculate variance. You use the variance to find the standard deviation. So what we're going to do is we're going to find the average distance something is from the mean. That's what standard deviation means, is how far away are you from the mean. Now, I gave you step-by-step instructions here, but I think it's easier to see with a table. But let's go through these step-by-step and then we'll apply it. So I want to find the median, x bar. I'm going to find the square of the differences between the data set and the mean. So in other words, I'm going to take I'm going to take my mean, and I'm going to subtract my data set, and then I'm going to square that. And I'll explain why we square that in a second. We find the sum, and then we divide that to find the average. When you do that, that's called the variance. But we've squared it, so your units aren't going to correspond. So finally to find it, we'll take the square root of that answer. Now that's a lot of things to keep track in your short-term memory. So let's go through this one step at a time. We're going to make a table here. So it says Leo tracked his homework scores for the past week. 100, 0, 150, 0. Well, just by inspection, I can see his average score was 50. Is that representative of what he knew or what he did? So I'm going to write down my values in a table. So I'm going to go 100, 0, 100, 50, and 0. Then what we're going to do is we're going to find the mean. Well, we know our mean is 50 because we can see we have 2 100s, 2 zeros, and a 50. So then what I'm going to do is I'm going to take my mean and I'm going to subtract each term. So 100 minus 50 is 50. 0 minus 50 is negative 50. Whoops, got an extra 0 in there. 100 minus 50 is 50 again. 50 minus 50 is 0. And 0 minus negative 50, or 0 minus 50 is negative 50. Now, if I took each of these values and added them up, notice I'd get 0, because that's the average. So what happens is we want to punish the data from being far away from the mean. And I'm going to keep everything positive. So then at this point, I'm going to take each one of these numbers and I'm going to square it. So 50 squared is 2,500. Negative 50 squared is also 2,500. 50 squared, we already did, is 2,500. 0 squared is 0. And then 2,500. Then to find the variance, we're going to find the average of these numbers. Well, we see here, I've got 5,000 plus 5,000. So I've got 10,000. And I'm going to divide that by how many data points I have, which is 1, 2, 3, 4, 5. So then, if you take 10,000 divided by 5, that would be 2,500. Finally, to find the standard deviation, and we use the Greek letter sigma. That's what that means. That means standard deviation. I'm going to take the square root of 2,500. If I take this, let me make sure something's not kosher here. Okay, if I take 10,000 and divide it by 5, I get 2,000. Man, that was not smart. That's 2,000. Let's try that again. Sorry about that. Try to do things in my head and not very smart. So then I'm going to take the square root of 2,000. and we get about 44.7. Now, let's interpret that. Well, notice 44.7, that's almost the same as my mean, isn't it? And since it's such a huge number, it means my data set is not very representative of my knowledge, okay? It deviates greatly from the mean. We only use standard deviation if you don't have any outliers, because the outliers really affect the standard deviation. Because notice what happens here. When you squared this value, it got really big really quick, didn't it? Since it got really big really quick, then that's not very good. That's not a very good representation of the data.